distribution video where we're going to be doing Poisson distribution. So in this video, I'm just going to show you guys how to calculate probabilities if it follows the Poisson distribution. So the formula for Poisson distribution, it's given as follows. So it's P of, let me just zoom out a little bit to make the size better. P of X equals to X equates to the probability of X as, so I would like to simplify it. This is the one that you'll find in your books. So I'm just going to simplify it. You see why I simplify it to the form that I've simplified as. So this is, so try to do that. So I'll simplify it to, you'll see how I do it now. So I'll just simplify it to lambda over on top of X, and it's e to the power of lambda, and it's X of that. So it's like just one thing. So this will be our PX. So the PX value just gives as follows. So let me just write it neater here. So we have lambda to the power of X divided by E, which is Euler's number, divided by to the power of X to the power of lambda, and then what is it, factorial, X factorial. So now what is lambda and what is E? E is Euler's number, so we know that E is basically that number that is defined on a calculator. So if you, it's a constant basically. And then lambda, what is lambda? Lambda is a mean of success in a specified interval. So lambda will be that just mean basically. And then X will be the value that you're looking at. Like say the X values will be from 0, 1, 2, 3, 4, 5, 6. So if you say P of X is equals to 2, then you're focusing on these values. So let's say you have Y probability there, then that's the probability that's given at that part. So that's the X values. These are the X values. And this one will be the PX values. So it's, yeah, so that's how it works basically. So now let's look at the question involving Poisson distribution. So this is the question from the study guide in statistics STSA 1624. So on the study guide, it's labeled as example 3.6. So in a study of a drug induced anaphylaxis among patients taking rocuronium bromide as part of their anesthesia, it was found that the occurrence of anaphylaxis followed a Poisson distribution with the mean of that one. So I would like you to just basically highlight this part, the mean of that one, incidents per year. So just note it as this is the, you just write it as mean per year. So however you indicate it, so this will be which is 12 per year, right? Let me just write it like that. So I don't mind how I wrote year there, just write it simplified. So this is per year, 12, with the magnitude of 12 per year. So now let's say find the probability that among the patients receiving rocuronium in the next year, exactly 3 will experience that anaphylaxis. So now you're looking at the probability of X equates to 3, exactly 3. And so they say find the probability among the percent of this one the next year. note that it's still talking about a year. They're not talking about a month or whatever. Exactly 3 will experience that. So you're just looking at that. So remember, we simplified our formula to this part. Where is it? There, which is lambda lambda to the power of x divided by e to the power of lambda, and then this is x factorial. So that's our formula. So now we're just going to substitute our values. So lambda, let's just declare our values real quick. So for the first question, lambda is given as 12, and then x, it's asking for x where x equals to 3, and then that's all you need for the question. So you have 12 to the power of 3 divided by e to the power of 12, and then this is 3 factorial. So now put this in your calculator the way it is. So to put it is 12. If you're doing this for the first time and you don't know what factorial is, you just press 12 to the power of 3, and then it is divided by which is shift E, which is the shift of ln, natural logarithm, on your Casio calculator, and then it will be to the power of 12, and then you just move your space to 3, which is times 3. Factorial, it is given as if you next to logarithm, the one with base 10 on top of it, there will be your factorial, which is shift that x, and then you get your exclamation mark. So that's how you do it. When you press the equal sign, you should get your answer as 0.0017695. It continues. So I'm just going to run it off to like 2 significant figures. So it will be 0.0018. So that's your final answer for that question. And then the next question says, so this is number 1. So now we're going to look at number 2. So the next question says, they say calculate the probability that among the patient receiving a roconium. Sorry, is it roconium? Yeah, I don't know if I'm spelling that correctly, but anyway, in the next 6 months, more than 2 will experience that one. So you're looking at more than 2, not 2, but more than 2. So 2 is not included. So it's x greater than 2. And then now note that your lambda changed because it was 12. Now it's 6 because you're looking at 6 months, which is half of the full year. So you're looking at 6 months. So lambda is basically divided by 2. So that's your mean. So your mean will be basically 6 at this moment. But your x now, you're looking at it varying x values. So you can say it is also equals to, when are you going to stop on this one? You don't know. So it's better to say it is just a complement of this one, which is p of x less than equal to 2. And that's the complement of this guy. Now we can work out this one because we know how to do that. So it is basically 1 minus, let's put a bracket there. It is p of x equals to 0. And then it's plus p of x equals to 1. And then it is plus p of x equates to 2. And then now let's close our bracket. So this will be 1. We know that it is minus. Let's just write that lambda. So it's lambda of x. Remember our formula is there. It's right here. So we're just going to put that formula in there. We know that our lambda is 6. So 6 to the power of 0 divided by e to the power of lambda, which is e to the power of that's e to the power of 6, and then it's x to the power, which is 0. So it's 0 factorial. That would just come out as 1. So it's plus 6 to the power of 1 divided by e to the power of 6. And then this will be your 1 factorial. And then it's plus 6 to the power of 2 divided by e to the power of that 6, because that doesn't change. And then you have 2 to the 2 factorial. So 2 factorial is still 2. 1 factorial is still 1. 0 factorial is still 0. Sorry, 1. Because if it becomes 0, then that becomes undefined. So we would have a problem. So it becomes 1. So now we can just rewrite this one as 1 over e to the power of 6. And then this is plus 6 divided by e to the power of 6. And this is plus, that's just 36 over 2e to the power of 6. Okay. Which comes down to something simplified. And then we just need to do that. And then this is 1 minus that. So let's just put this in a calculator and get our values. So if you put it in a calculator real quickly, you'll get that. Let me just do this. I already worked out this thing, so it shouldn't give me a problem. So you'll get that these values will give you 0.06196. Of course, you'll get a long number, so you just need to round it off, and then you have your answer is 0.9380. So that's your final answer for this question. And this is basically how you tackle a normal distribution question. Sorry, Poisson distribution questions. And they're very easy. You shouldn't be complicated them or anything like that. So I'm just gonna cut this video for now and do a normal distribution.